In our exploration of the Milky Way, we have come to understand the delicate balance of forces that shape galaxies, the life cycles of stars, and the birth of planets. We have discovered exoplanets that may harbor the conditions necessary for life, and we are beginning to glimpse the fundamental nature of dark matter and dark energy. Yet, with each new discovery, we are faced with more questions. Questions about the universe's ultimate fate, the possibility of extraterrestrial life, and the role that we, as intelligent beings, will play in the galaxy's future. The Milky Way, with its swirling spiral arms and ancient core, is both a time capsule and a frontier. It holds the remnants of past cosmic events while pointing us toward the future, toward the merging of galaxies, the search for life among the stars, and the ongoing expansion of the universe. As we continue to explore, the Milky Way will remain our guide, urging us to look beyond our immediate surroundings and embrace the grander cosmic narrative. In the end, the Milky Way is more than just our galactic home. It is a testament to the power of exploration, the resilience of the human spirit, and the boundless potential of knowledge. It reminds us that, while we may be small in the grand scheme of the universe, we are part of something infinitely larger and more wondrous than we can fully comprehend. The journey through the Milky Way is far from over, and as we continue to explore, we are not only uncovering the mysteries of the cosmos, but also discovering the true nature of ourselves. In this vast galaxy, filled with beauty, mystery, and potential, we find not only answers to the questions of science, but also a profound sense of connection to the universe, a reminder that our quest for knowledge and understanding will always drive us to reach for the stars. In the grand tapestry of the universe, the Milky Way stands as a testament to the beauty and complexity of cosmic evolution. It is a place of birth and death, of creation and destruction, where the forces of nature play out on scales that dwarf our everyday experience. Yet, despite its vastness, the Milky Way is also deeply connected to our own lives. It is the galaxy that gave rise to the Sun, the Earth, and all life as we know it. It is a reminder that we are part of something far larger than ourselves, an interconnected web of matter and energy that stretches across time and space. As we look to the future, the Milky Way remains a source of wonder and inspiration. Its mysteries, both solved and unsolved, challenge us to continue exploring, to ask the big questions, and to push the boundaries of human knowledge. Whether we are studying the birth of stars, searching for life on distant planets, or contemplating the ultimate fate of the universe, the Milky Way offers a gateway to understanding the deepest aspects of existence. In the end, the Milky Way is more than just a galaxy. It is a symbol of humanity's quest to explore the unknown. It represents our desire to understand the universe and our place within it, a journey that has spanned millennia and will continue for generations to come. As we continue this journey, we are reminded that the story of the Milky Way is, in many ways, our own story, a story of discovery, curiosity, and the unquenchable human spirit. The ongoing exploration of the Milky Way is not just a scientific pursuit, but a testament to the human spirit, a reflection of our innate curiosity and determination to reach beyond the confines of our world and understand the universe. As we continue to delve into the depths of our galaxy, we are uncovering not only the secrets of the cosmos, but also our own capacity to imagine, innovate, and adapt. Each new discovery is a reminder that the Milky Way is far more than a distant collection of stars. It is a living, evolving system that holds the key to our past, present, and future. One of the most exciting frontiers of exploration within the Milky Way is the study of exoplanets, planets orbiting stars beyond our solar system. The discovery of thousands of exoplanets in the past few decades has transformed our understanding of the galaxy. We now know that planets are abundant in the Milky Way, and many of them are located in the habitable zone of their stars, where conditions might be right for liquid water to exist, a key ingredient for life as we know it. This has opened up the tantalizing possibility that life could exist elsewhere in the galaxy, perhaps on planets orbiting stars that are only a few light years away from Earth. The search for habitable exoplanets has become one of the most active areas of research in astronomy. Missions like NASA's Kepler and TESS Transiting Exoplanet Survey satellite have identified thousands of candidate exoplanets, and the James Webb Space Telescope is set to study the atmospheres of some of these distant worlds in unprecedented detail. By analyzing the light that passes through an exoplanet's atmosphere as it transits in front of its star, scientists can detect the presence of molecules like water vapor and methane, potential indicators of life. Finding life on another planet would be one of the most profound discoveries in human history. It would suggest that the processes that gave rise to life on Earth are not unique, but are part of a universal pattern, unfolding wherever the right conditions exist. This realization would not only deepen our understanding of biology and evolution, but also expand our sense of connectedness to the cosmos. Life, it seems, may not be confined to a small, rocky planet orbiting an average star in a quiet corner of the Milky Way. It may be a common feature of the galaxy, woven into the very fabric of the universe. The implications of finding extraterrestrial life are far-reaching, not just scientifically but philosophically and ethically. How would humanity react to the discovery of life beyond Earth? Would it unite us in a shared sense of purpose, or would it challenge our view of ourselves as the dominant intelligent species in the universe? And if we were to encounter intelligent life, what responsibilities would we have toward those beings? These are questions that go beyond the realm of science, touching on the deepest aspects of human identity and our place in the universe. Even as we search for life on distant planets, we are also learning more about the unique conditions that make Earth habitable. Our planet exists in a delicate balance, protected by its atmosphere, magnetic field, and distance from the Sun. This Goldilocks zone has allowed life to flourish on Earth for billions of years, but it also serves as a reminder of how rare and fragile life may be in the galaxy. The study of exoplanets helps us understand the factors that contribute to habitability, providing valuable insights into how planets evolve and how life might emerge elsewhere in the Milky Way. At the same time, the exploration of the Milky Way is helping us understand the broader processes that govern the galaxy. Dark matter, which makes up the majority of the Milky Way's mass, continues to elude direct detection, yet its presence is inferred from the gravitational effects it has on stars and galaxies. Dark matter is thought to form a vast halo around the Milky Way, influencing the motion of stars and the structure of the galaxy itself. Understanding the true nature of dark matter is one of the biggest challenges in modern physics, and it could unlock new insights into the fundamental forces that shape the universe. The study of dark matter is closely linked to the search for dark energy, the mysterious force that is driving the accelerated expansion of the universe. While dark matter holds galaxies together, dark energy pushes them apart, causing the universe to expand at an ever-increasing rate. The discovery of dark energy has revolutionized our understanding of cosmology, raising profound questions about the fate of the universe. Will the Milky Way continue to exist as part of a larger cosmic structure, or will dark energy eventually push galaxies so far apart that they become isolated in a vast, empty universe? These questions are not just theoretical, they have real implications for the future of the Milky Way and the universe as a whole. As we continue to study the forces that govern the galaxy, we are gaining a deeper understanding of how the Milky Way will evolve over time. In a few billion years, the Milky Way will merge with its neighbor, the Andromeda Galaxy, creating a new, larger galaxy. This event, while dramatic, is part of the natural life cycle of galaxies, which grow and change through mergers and interactions with other galaxies. The stars and planets within the Milky Way will continue to orbit the galactic center, but the structure of the galaxy will be fundamentally transformed. Beyond this distant future, the ultimate fate of the Milky Way is tied to the fate of the universe itself. If dark energy continues to drive the expansion of the universe, the galaxies within the local group, including the Milky Way, may eventually become isolated in a vast empty cosmos. Over billions of years, the stars within the galaxy will burn out, leaving behind cold, dead remnants, white dwarfs, neutron stars, and black holes. The Milky Way, once a vibrant, dynamic system, will slowly fade into darkness, a relic of a universe that once teemed with life and energy. Yet, even in this distant, somber future, the story of the Milky Way remains one of hope and inspiration. It is a reminder that we are part of a cosmic journey that stretches across time and space, a journey that has been unfolding for billions of years and will continue long after we are gone. The Milky Way is not just a galaxy, it is a symbol of humanity's desire to explore, to understand, and to push the boundaries of knowledge. As we look to the future, the Milky Way offers us both a challenge and an opportunity. It challenges us to continue exploring, to seek out new knowledge, and to confront the mysteries of the universe. But it also offers us the opportunity to reflect on our place in the cosmos, to appreciate the beauty and complexity of the galaxy, and to recognize the interconnectedness of all things. The journey of discovery within the Milky Way is far from over. With each new mission, each new observation, we are uncovering new layers of understanding, revealing the intricate dance of stars, planets, and galaxies that make up our universe. The Milky Way, in all its complexity and wonder, will continue to inspire generations of scientists, explorers, and dreamers as we seek to understand the universe and our place within it. And in this quest for knowledge, we are not just learning about the galaxy, we are learning about ourselves, about the forces that shape our existence, and about the infinite possibilities that lie ahead. The Milky Way stands as a majestic reminder of both the vastness of the universe and our intricate connection to it. As we continue to unravel the galaxy's mysteries, we are reminded that it is far more than just a collection of stars, gas, and dark matter. It is the cosmic cradle that gave birth to our solar system, the framework within which we search for life beyond Earth, and a mirror reflecting humanity's endless curiosity. Dark energy, another mysterious force, is responsible for the accelerated expansion of the universe. While dark matter holds galaxies together, dark energy is pushing them apart, driving the universe to expand at an ever-increasing rate. The discovery of dark energy in the late 20th century was one of the most surprising findings in cosmology, and it has raised fundamental questions about the fate of the universe. Will the Milky Way continue to exist as part of a galaxy cluster, or will dark energy eventually drive galaxies so far apart that the universe becomes a cold, empty void? The interplay between dark matter, dark energy, and the visible matter that makes up stars and galaxies is one of the great cosmic mysteries. By studying the Milky Way, we are not only learning about our own galaxy, but also gaining insights into the fundamental forces that govern the universe. As we unravel these mysteries, we come closer to understanding the grand cosmic story that has been unfolding since the Big Bang. Yet, even as we push the boundaries of our knowledge, the Milky Way remains a source of inspiration and wonder. Its beauty, as seen in the night sky, has captivated humanity for millennia, prompting us to ask the big questions about our existence and our place in the universe. The more we learn about the galaxy, the more we realize how interconnected everything is, from the stars that shine in distant regions of space to the atoms that make up our bodies. This sense of connectedness is both humbling and empowering, reminding us that we are part of a much larger cosmic story. The future of our exploration of the Milky Way is bright. With each new mission, each new discovery, we gain a deeper understanding of the galaxy and our place within it. But this journey is far from over. The Milky Way is vast, and we have only just begun to scratch the surface of its mysteries. There are still countless stars, planets, and phenomena waiting to be discovered, each one offering new insights into the nature of the universe. As we continue to explore, we are reminded that the Milky Way is not just a distant, impersonal object in space. It is our home. It is the galaxy that gave rise to the Sun, the Earth, and all life as we know it. And as we look to the stars, we are not only searching for answers about the cosmos, we are seeking to understand our own origins, our future, and our connection to the universe. The story of the Milky Way is, in many ways, the story of humanity's quest to understand the universe. It is a journey that has spanned millennia, from the earliest stargazers who marveled at the band of light stretching across the night sky to the modern scientists who probe the farthest reaches of the galaxy with powerful telescopes. It is a story of exploration, discovery, and wonder, a story that continues to unfold with each new generation. As we move forward into the future, the Milky Way will remain both a symbol of our past and a beacon of hope for the discoveries that lie ahead. The story of the Milky Way continues to unfold, layer by layer, revealing a universe far more intricate and mysterious than we ever imagined. As we venture deeper into our understanding of this galaxy, we realize that its significance transcends the physical. It touches the very core of what it means to explore, to seek knowledge, and to grapple with our place in a vast and ancient cosmos. One of the most remarkable aspects of the Milky Way's ongoing evolution is how it serves as a time machine, offering us glimpses into different eras of cosmic history. When we observe distant stars and nebulae, we are looking back in time. The light from these objects takes thousands, sometimes even millions of years to reach us. The farthest edges of the galaxy preserve relics of its past, from ancient star clusters formed in the galaxy's infancy to the remnants of stars that exploded long before humanity emerged. By studying the Milky Way, we are not only learning about the present state of the galaxy, but also about the events that shaped its formation over billions of years. Our place within this grand cosmic timeline can be both humbling and awe-inspiring. The Milky Way, with its 13.6 billion-year history, has witnessed the birth of stars, the formation of planets, and the cycles of galactic collisions and mergers. Compared to these vast timescales, human civilization is but a fleeting moment. Yet, despite this, we are the first known species within this galaxy capable of reflecting on its existence, capable of studying the stars and unlocking the mysteries of the universe. This realization not only highlights the preciousness of life on Earth, but also underscores our responsibility to protect it and to continue seeking knowledge. As we continue to explore the Milky Way, one of the most promising frontiers is the study of star formation. Massive regions of the galaxy, such as the Orion Nebula, are filled with gas and dust, raw materials that collapse under the force of gravity to form new stars. These stellar nurseries are hotbeds of cosmic activity, where stars ignite and planetary systems begin to take shape. Studying these regions helps scientists understand how stars like our Sun were born and how planetary systems, including potentially habitable worlds, come into being. Understanding the life cycles of stars is also critical for piecing together the future of the Milky Way. Stars of different masses live vastly different lives. Small, cool stars like red dwarfs burn slowly and can live for tens of billions of years, while massive stars burn brightly but quickly, often ending their lives in dramatic supernova explosions. These supernovae are crucial events in the galactic ecosystem as they forge heavy elements like iron, gold, and uranium, which are then scattered into space to become part of future generations of stars and planets. Our own solar system was born from the remnants of such stellar explosions, and the elements in our bodies were once part of stars that lived and died long ago. In the far future, the Milky Way itself will undergo profound changes. As previously mentioned, the impending collision with the Andromeda Galaxy will radically reshape the galactic landscape. This merger, said to occur in about 4 billion years, will result in the formation of a new galaxy. The Milky Way and Andromeda, currently separated by 2.5 million light-years, are slowly being drawn together by their mutual gravitational pull. While the stars themselves are unlikely to collide due to the vast distances between them, the gravitational forces at play will cause both galaxies to warp and stretch, merging into a new, larger elliptical galaxy. The night sky on Earth, or on any future planets, will be transformed as Andromeda grows larger and eventually merges with the Milky Way, creating a galactic dance that will span millions of years. This event is part of a larger process of cosmic evolution that has been ongoing since the birth of the universe. Galaxies are not static entities. They are constantly changing, interacting with one another, and evolving over time. The Milky Way's merger with Andromeda will mark the next major chapter in its history. But it is just one of countless galactic collisions and mergers that have occurred throughout the universe. These cosmic interactions are part of the natural life cycle of galaxies, and they play a crucial role in shaping the large-scale structure of the universe. At the same time, the future of the Milky Way will also be influenced by the larger forces at work in the universe, particularly the mysterious phenomenon of dark energy. Dark energy, which makes up about 70% of the universe's total energy content, is driving the accelerated expansion of the universe. Over billions of years, this expansion will cause galaxies outside the local group to move farther and farther away from us, eventually disappearing beyond the observable horizon. In this distant future, the Milky Way, Andromeda, and a few other nearby galaxies will be isolated in a vast, empty universe. The stars within the galaxy will continue to burn, but as they die out over time, the galaxy will grow darker and colder, until only the faint glow of white dwarfs and black holes remains. Despite this distant and somber future, the Milky Way still offers untold opportunities for discovery in the present. With the advent of new observational tools, such as the James Webb Space Telescope and future missions, we are poised to learn more about the galaxy than ever before. These instruments will allow us to study the atmospheres of exoplanets, search for signs of life, and probe the most distant regions of the galaxy, revealing new insights into its structure and history. The search for extraterrestrial life remains one of the most compelling endeavors in modern science. The discovery of even microbial life on another planet would fundamentally change our understanding of biology and the nature of life itself. It would suggest that life is not a rare accident, but a natural consequence of the processes that occur throughout the universe. Such a discovery would raise profound philosophical and ethical questions about our place in the cosmos and how we should interact with other forms of life, should they exist. In this sense, the study of the Milky Way becomes more than just a scientific endeavor. It becomes a quest for meaning. The galaxy is a vast, ancient structure, stretching across time and space, and within its stars and planets may lie the answers to some of humanity's deepest questions. Are we alone in the universe? What is the nature of life? How did the universe come into being, and what is its ultimate fate? These are questions that have driven human curiosity for millennia, and as we explore the Milky Way, we move closer to finding answers. The study of dark matter and dark energy, two of the most mysterious forces in the universe, also plays a crucial role in this quest for understanding. While dark matter holds galaxies together, dark energy is driving the expansion of the universe at an accelerating rate. Together, they make up roughly 95% of the universe's total mass-energy content, yet we still know very little about their true nature. Unlocking the mysteries of dark matter and dark energy could lead to a new era of physics, providing insights into the fundamental forces that govern the cosmos. In this way, the Milky Way is a gateway to understanding not just our galaxy, but the entire universe. The processes that shape stars, planets, and galaxies in the Milky Way are universal, reflecting the same laws of physics that apply throughout the cosmos. By studying our galaxy in detail, we gain insights into the formation and evolution of all galaxies, from the smallest dwarf galaxies to the largest galaxy clusters. The Milky Way serves as a model for understanding the structure and behavior of the universe as a whole. But beyond the scientific and philosophical questions, the Milky Way also inspires a sense of awe and wonder. Its beauty is seen in the glowing band of stars that stretches across the night sky, has captivated humanity for millennia. The sheer scale of the galaxy, with its hundreds of billions of stars and countless planets, reminds us of the vastness of the universe and the smallness of our own existence within it. Yet, at the same time, the Milky Way also connects us to the cosmos in a deeply personal way. The elements that make up our bodies were forged in the hearts of stars, and the same forces that govern the movement of galaxies also shape our everyday lives. This cosmic perspective, sometimes referred to as the overview effect, has a profound impact on those who experience it. Astronauts who have seen the Earth from space often speak of a deep sense of interconnectedness with the planet and the universe. From the vantage point of space, national borders disappear, and the Earth becomes a fragile, beautiful world floating in the vastness of space. The Milky Way, seen in this context, becomes not just a distant galaxy, but a symbol of the interconnectedness of all things, of life, the Earth, and the universe itself. As we continue to explore the Milky Way, we are reminded that this journey is not just about answering scientific questions, it is about seeking a deeper understanding of our place in the universe. The more we learn about the galaxy, the more we realize how much there is still to discover. Each new observation, each new discovery, brings us closer to understanding the grand narrative of existence, from the formation of the first stars to the emergence of intelligent life. In the end, the Milky Way is a reminder that we are part of something much larger than ourselves. It is a testament to the power of the universe's creative forces. A cosmic system has been evolving for billions of years and will continue to evolve long after humanity is gone. As we explore its stars, planets, and mysteries, we are not just learning about the galaxy, we are learning about the forces that have shaped our own existence and the possibilities that lie ahead. The Milky Way is both a symbol of our past and a guide to our future. It represents the legacy of billions of years of cosmic evolution, but it also holds the promise of future exploration and discovery. As we continue to study the galaxy, we are reminded that the journey of discovery is never complete. There will always be new questions to ask, new mysteries to unravel, and new horizons to explore. The Milky Way, in all its complexity and wonder, will continue to inspire generations of explorers, scientists, and dreamers as we seek to understand the universe and our place within it. The ongoing exploration of the Milky Way mirrors humanity's own journey, one of endless curiosity, resilience, and the pursuit of knowledge. The galaxy serves as both a vast archive of cosmic history and a frontier for future discovery. As we stand on the precipice of this knowledge, we begin to realize just how interconnected we are with the forces that govern the universe, from the smallest particles to the largest galactic structures. This recognition that we are not isolated in the cosmos, but a part of its intricate web, has profound implications for the way we understand our place in the universe. One of the most remarkable aspects of the Milky Way is the constant evolution that takes place within it. Stars are born, live out their lives, and eventually die, sometimes in dramatic supernova explosions that seed the galaxy with the elements necessary for future star systems and even life. This cycle of creation and destruction plays out on timescales far beyond human comprehension, yet it is responsible for everything we see around us. Each star in the night sky is part of this grand cosmic cycle, contributing to the ongoing story of the Milky Way. Our own Sun is a middle-aged star, quietly fusing hydrogen into helium in its core. It sits in the Orion arm of the Milky Way, orbiting the galactic center once every 230 million years in a journey known as the galactic year. But the Sun is just one of billions of stars in the galaxy, and like all stars, it has a finite lifespan. In about 5 billion years, the Sun will exhaust its supply of hydrogen and begin to expand into a red giant, eventually shedding its outer layers and leaving behind a white dwarf, an inert, dense remnant of its former self. The material it sheds will enrich the interstellar medium, contributing to the formation of future stars and planets, just as our own solar system was formed from the remnants of earlier generations of stars. This cycle of stellar life and death is one of the most fundamental processes in the universe, and it is ongoing throughout the Milky Way. Regions like the Orion Nebula and the Eagle Nebula are nurseries for new stars, where clouds of gas and dust collapse under gravity to form young, hot stars. These regions are not only beautiful but also essential to our understanding of how stars and planetary systems form. By studying these stellar nurseries, astronomers can learn more about the conditions that gave rise to our own solar system, providing insight into the origin of planets and life. In the same way that stars and planets are born from the materials left behind by previous generations, life itself may also be part of a broader cosmic process. The discovery of thousands of exoplanets orbiting stars within the Milky Way has revolutionized our understanding of planetary systems and has opened up the possibility that life may exist elsewhere in the galaxy. The search for life beyond Earth, whether microbial or complex, is one of the most exciting endeavors in modern science. Instruments like the James Webb Space Telescope are poised to study the atmospheres of distant exoplanets, searching for the chemical signatures of life. If life is found elsewhere in the Milky Way, it would suggest that the processes that led to life on Earth are not unique but are part of the natural evolution of planetary systems throughout the galaxy. This would have profound implications for our understanding of biology, evolution, and the nature of life itself. It would also raise questions about the future of humanity. If life can arise on other planets, what role will we play in exploring and possibly interacting with these distant worlds? The potential for life elsewhere in the galaxy also challenges us to think about the ethical and philosophical implications of our exploration. How would we interact with extraterrestrial life should we find it? What responsibilities do we have to protect these distant ecosystems? And how would the discovery of life beyond Earth change our understanding of humanity's place in the universe? These are questions that go beyond science, touching on the deeper philosophical and ethical considerations of what it means to be part of a living, evolving cosmos. As we search for life beyond Earth, we are also learning more about the forces that shape the Milky Way itself. Dark matter, which makes up the majority of the galaxy's mass, remains one of the greatest mysteries in modern astrophysics. Although we cannot see dark matter directly, its gravitational effects are evident in the rotation curves of galaxies and the large-scale structure of the universe. Without dark matter, galaxies like the Milky Way would not be able to hold themselves together, and the universe would look very different. Understanding the true nature of dark matter is one of the key challenges facing scientists today, and solving this mystery could revolutionize our understanding of the universe. One of the key insights in recent years has been the discovery that the Milky Way has absorbed several smaller galaxies over its history. These galactic mergers are part of a natural process of growth and evolution that is common among large galaxies. The Sagittarius dwarf galaxy, for example, is currently in the process of being torn apart and assimilated by the Milky Way's gravity. The stars from this dwarf galaxy are gradually being distributed along a stellar stream that wraps around the Milky Way, adding new material to our galaxy's halo. Similar mergers have occurred throughout the Milky Way's history, and evidence of these past events can be found in the form of ancient stellar streams and globular clusters that once belonged to smaller galaxies. These mergers not only add stars to the Milky Way, but also contribute to the overall mass of dark matter that surrounds the galaxy. Dark matter, while invisible, plays a crucial role in holding galaxies together. Without the gravitational influence of dark matter, galaxies like the Milky Way would not have enough mass to account for the observed motions of stars and gas. The halo of dark matter that envelops the Milky Way is believed to extend far beyond the visible disk of stars, creating a gravitational well that shapes the galaxy's structure and influences its interactions with other galaxies. One of the great mysteries surrounding dark matter is its true nature. Despite its significant role in the evolution of the Milky Way, scientists still do not know what dark matter is made of. Various theories have been proposed, including the possibility that dark matter is composed of weakly interacting massive particles, WIMPs, or other exotic particles that do not interact with light. Researchers are currently conducting experiments both on Earth and in space to detect these particles and learn more about how dark matter shapes galaxies. Unlocking the mystery of dark matter could revolutionize our understanding of the universe and reveal new aspects of physics that have yet to be discovered. In addition to mergers with smaller galaxies, the Milky Way is set to undergo a much larger and more dramatic collision in the distant future. The Andromeda Galaxy, which is the Milky Way's closest large neighbor, is on a collision course with our galaxy. Although this event is still billions of years away, it will result in a major restructuring of both galaxies. When the Milky Way and Andromeda collide, their stars will not actually crash into one another due to the vast distances between them, but the gravitational forces of the collision will warp and reshape both galaxies. Over time, the two galaxies will merge to form a new, larger galaxy, possibly an elliptical galaxy, as the spiral structures of both systems are disrupted. This merger will be a defining moment in the future history of the Milky Way, and marks one of the many ways in which galaxies evolve over cosmic time. Despite the dramatic changes that will occur during this merger, it is unlikely to have a significant impact on the individual stars and planetary systems within the Milky Way. However, the night sky will look radically different for any future observers on Earth or on another planet. As Andromeda approaches, it will become a prominent feature in the sky, growing larger and more brilliant over time until the two galaxies blend together. This cosmic dance between the Milky Way and Andromeda is a reminder that even galaxies are subject to the forces of nature, constantly interacting and evolving over billions of years. But beyond the physical evolution of the Milky Way, there is also the question of what the future holds for humanity's place within the galaxy. As we continue to develop our technological capabilities, the possibility of interstellar travel becomes increasingly plausible. While the distances between stars are immense, measured in light years rather than kilometers, advances in propulsion technology could one day allow us to travel to other star systems. Projects like Breakthrough Starshot, which aims to send tiny high-speed spacecraft to the nearest star system, Proxima Centauri, represent the first tentative steps toward exploring the stars beyond our solar system. While these missions are still in their infancy, they offer a glimpse of what the future of human exploration could look like. The discovery of exoplanets, particularly those in the habitable zones of their stars, has further fueled the dream of interstellar exploration. The search for life on other planets is one of the driving forces behind many space missions, and the Milky Way, with its vast array of star systems, offers countless opportunities for discovering habitable worlds. The potential for life elsewhere in the galaxy raises profound questions about our place in the universe. If life is found on other planets, it would suggest that the processes that led to life on Earth are not unique, but a part of the natural evolution of the cosmos. Such a discovery would have far-reaching implications for our understanding of biology, evolution, and the nature of life itself. As we look toward the future, it is clear that the Milky Way will continue to be a focal point for scientific discovery and exploration. The galaxy, in all its complexity, offers a wealth of opportunities for understanding the fundamental forces that govern the universe. Whether we are studying the life cycles of stars, searching for signs of dark matter, or probing the atmospheres of distant exoplanets, the Milky Way serves as a natural laboratory for investigating the mysteries of the cosmos. Yet, despite all that we have learned, the Milky Way remains a source of wonder and inspiration. Its beauty, as seen in the band of light that stretches across the night sky, has inspired countless generations of thinkers, artists, and explorers. As we continue to delve deeper into its secrets, we are reminded that the Milky Way is not just an object of scientific inquiry, it is a symbol of humanity's unending curiosity and desire to explore the unknown. In the end, the Milky Way serves as both a physical home and a philosophical touchstone. It represents the known universe, the boundary of our current exploration, but also the limitless potential for future discovery. As we strive to uncover the galaxy's mysteries, we are also searching for our own place within the cosmic order, seeking to understand how we fit into the grand narrative of the universe. The Milky Way is, in many ways, a reflection of our own journey, a journey of exploration, discovery, and wonder that stretches across both time and space. The journey of discovery within the Milky Way is far from complete. As we continue to develop new technologies, explore the outer edges of space, and push the boundaries of human understanding, we find that each question we answer gives rise to new mysteries, inviting further exploration. The Milky Way, with its sprawling arms, ancient stars, and hidden dark matter, remains a cosmic puzzle that will occupy the minds of scientists, philosophers, and dreamers for centuries to come. One of the key areas where exploration is ongoing is the search for Earth-like planets in the habitable zones of their stars. The discovery of such planets not only raises the tantalizing possibility of life beyond Earth, but also sparks our imagination about the future of humanity. If these planets can support life, they may offer a second home for humanity in the distant future. This dream of colonizing other worlds, once purely the domain of science fiction, is now being considered as a potential long-term goal for space exploration. Mars, while not within another star system, represents humanity's first major step toward becoming an interplanetary species. With numerous missions aimed at studying its surface, atmosphere, and potential for future habitation, Mars offers a glimpse into what is possible within our own solar system. But beyond Mars, the exoplanets of the Milky Way offer far grander possibilities. In the coming decades, missions like the James Webb Space Telescope and other next-generation observatories will help us identify more Earth-like planets, providing key data about their atmospheres, climates, and potential habitability. However, the challenges of interstellar travel are immense. The vast distances between stars mean that even the closest exoplanets are many light years away. This makes travel to these distant worlds a monumental task, requiring breakthroughs in propulsion technology, energy storage, and life support systems. Nevertheless, the dream of reaching the stars persists, and many scientists and engineers are already working on the concepts that could one day make interstellar travel a reality. Concepts such as nuclear fusion propulsion, light sails powered by lasers, or even the theoretical idea of wormholes are being explored as potential solutions to the problem of traveling across the galaxy. The exploration of the Milky Way is not just a technical challenge, it is also a deeply philosophical one. As we consider the possibility of life beyond Earth, we are confronted with questions about the nature of life itself. What defines a living organism? Could life exist in forms radically different from those we know on Earth? These questions are not just scientific in nature, they challenge our assumptions about existence, intelligence, and the limits of human knowledge. The discovery of life, whether microbial or intelligent, on another planet would fundamentally alter our understanding of biology and evolution, but it would also force us to reconsider our place in the cosmos. One of the most profound concepts to emerge from our study of the Milky Way is the realization that we are, quite literally, made of stardust. The atoms that make up our bodies, carbon, nitrogen, oxygen, and more, were forged in the hearts of ancient stars that lived and died long before the Earth even existed. These elements were scattered across the galaxy when those stars exploded as supernovae, enriching the interstellar medium with the building blocks necessary for life. Over time, this material coalesced to form new stars and planets, including our own solar system. In this sense, the story of the Milky Way is also the story of us, a story of cosmic origins that stretches back billions of years. This connection to the stars gives rise to a sense of unity with the universe that transcends the boundaries of time and space. As we explore the galaxy, we are not just studying distant objects, we are uncovering the deep roots of our own existence. Every star, every planet, every nebula we observe is part of the same cosmic fabric that gave rise to life on Earth. The Milky Way, in all its vastness, becomes a bridge between the past and the future, linking the birth of the universe to the emergence of conscious life. The notion of being part of such a vast, interconnected system raises profound questions about the future of humanity. As we learn more about the Milky Way and the forces that govern it, we are also faced with the question of what role we will play in the future of the galaxy. Will humanity remain confined to Earth, or will we one day spread out among the stars, exploring and inhabiting other worlds within the Milky Way? The possibilities are as vast as the galaxy itself. The idea of interstellar travel, once confined to the realm of science fiction, is now being seriously considered by scientists and engineers. While the technical challenges of traveling to other star systems are immense, the rapid pace of technological advancement suggests that it may one day be possible to send robotic probes or even human explorers beyond our solar system. Missions like Breakthrough Starshot, which aims to send tiny, lightweight spacecraft to the nearest star system, Alpha Centauri, represent the first steps toward this goal. If successful, such missions could open up a new era of exploration, allowing humanity to venture beyond the confines of our planetary neighborhood and begin the long journey across the Milky Way. But even as we dream of exploring other star systems, we are reminded that the Milky Way itself remains largely unexplored. Despite all of our advances in astronomy, we have only scratched the surface of what the galaxy has to offer. There are countless stars, planets, and celestial phenomena within the Milky Way that we have yet to discover. Some of these may hold the key to understanding fundamental questions about the universe, while others may offer clues about the potential for life beyond Earth. The search for extraterrestrial life is one of the most exciting and tantalizing frontiers of modern science. With the discovery of thousands of exoplanets in recent years, many of which are located in the habitable zones of their parent stars, the possibility that life exists elsewhere in the Milky Way has become a serious scientific question. The next generation of space telescopes, including the James Webb Space Telescope, will allow scientists to study the atmospheres of these distant worlds in unprecedented detail, searching for the chemical signatures of life. The discovery of life on another planet, even in its simplest form, would be one of the most profound discoveries in human history. It would suggest that life is not unique to Earth, but a common phenomenon in the universe. Such a discovery would have far-reaching implications for our understanding of biology, evolution, and the nature of life itself. It would also raise profound philosophical and ethical questions about our place in the universe. If we are not alone, what does that mean for our sense of identity as a species? How would we relate to other forms of life, and what responsibilities would we have toward them? The search for intelligent extraterrestrial life, through programs like SETI, Search for Extraterrestrial Intelligence, adds another layer of complexity to these questions. If we were to detect a signal from an advanced civilization within the Milky Way, it would not only confirm that we are not alone, but also challenge our assumptions about the nature of intelligence, culture, and civilization. What would such a discovery mean for human society? Would it unite us in the knowledge that we are part of a larger galactic community, or would it deepen existing divisions? These are questions that we may one day have to confront as our exploration of the Milky Way continues. In addition to the search for life, the study of the Milky Way also offers insights into the future of the universe itself. The galaxy is a living system, constantly evolving through the processes of star formation, supernovae, and galactic mergers. These processes are driven by the fundamental forces of nature. Gravity, electromagnetism, and the nuclear forces govern the behavior of matter and energy on all scales. By studying the Milky Way, scientists can gain a deeper understanding of these forces and how they shape the evolution of the universe. One of the most important areas of research in this regard is the study of dark matter and dark energy, two of the most mysterious and poorly understood aspects of the universe. Dark matter, which makes up about 85% of the matter in the universe, is responsible for holding galaxies like the Milky Way together. Without it, the gravitational forces of the visible matter would be too weak to prevent galaxies from flying apart. Dark energy, on the other hand, is thought to be responsible for the accelerated expansion of the universe, pushing galaxies farther apart over time. Understanding these two phenomena is crucial for understanding the ultimate fate of the Milky Way and the universe as a whole. As we look ahead, the future of the Milky Way remains an open question. In a few billion years, the galaxy will undergo a major transformation when it collides with its neighbor, the Andromeda Galaxy. This cosmic event, though distant in the future, will reshape the structure of both galaxies, creating a new, larger galaxy in the process. While this may seem like a violent and destructive event, it is also a natural part of the life cycle of galaxies. Stars and planetary systems will survive the collision, and new stars will be born from the gas and dust that are thrown together in the aftermath. The merger of the Milky Way and Andromeda is a reminder that the galaxy, like all things in the universe, is subject to the forces of change and evolution. In the end, the Milky Way stands as a testament to the power of human curiosity and the desire to understand the universe. As we continue to explore its depths, we are reminded that the galaxy is not just a distant, cold object in space. It is a dynamic, living system, full of wonder, mystery, and possibility. The more we learn about the Milky Way, the more we realize how little we truly know about the cosmos. But this sense of mystery is not a source of frustration, it is a source of inspiration, driving us to push the boundaries of knowledge and explore the farthest reaches of the universe. The Milky Way, in all its vastness and complexity, is both our home and our gateway to the stars. It is a place of birth and death, of creation and destruction, of life and the potential for life. It is a microcosm of the universe itself, reflecting the grand forces that shape all of existence. And as we continue our journey of discovery, we are reminded that the story of the Milky Way is not just the story of a galaxy, it is the story of humanity's quest to understand its place in the cosmos. The unfolding story of the Milky Way is, at its heart, the story of exploration, not only of the galaxy itself, but of humanity's enduring desire to seek out answers to some of the universe's most profound mysteries. As our technological capabilities advance, our view of the Milky Way continues to evolve, revealing new details about its structure, history, and future. What began as a celestial band of light in the night sky has, over centuries of scientific discovery, become one of the most studied and well-understood regions of the universe. Yet, even with all that we know, the Milky Way still holds countless secrets, beckoning us toward deeper exploration. One of the most intriguing questions we face is how the Milky Way fits into the broader tapestry of the cosmos. Although the galaxy is vast, containing hundreds of billions of stars, it is just one galaxy among an estimated 2 trillion others in the observable universe. What distinguishes the Milky Way, apart from being our home, is its rich history of interactions with other galaxies, and the unique position it holds within the local group of galaxies. Our understanding of these interactions is deepening with each new study, revealing a dynamic and evolving system shaped by the gravitational forces of its neighbors. In the end, the Milky Way is more than just a collection of stars, gas, and dark matter. It is a microcosm of the universe itself. Its dynamic, evolving nature reflects the larger processes that govern the cosmos, from the formation of galaxies to the birth and death of stars. By studying the Milky Way, we are not just learning about our galaxy, we are uncovering the fundamental principles that shape the universe, and in doing so, we are learning more about our own place in the grand cosmic story. The future of our exploration of the Milky Way is bright, and as we continue to probe its depths, we will undoubtedly uncover new mysteries and wonders. But perhaps the most important lesson of all is that the Milky Way, in all its vastness and complexity, is also a reminder of the profound connection between humanity and the universe. As we look up at the night sky, we are not just observing distant stars and galaxies, we are gazing into our own cosmic origins, tracing the path of existence from the earliest moments of the universe to the distant future that lies ahead. The Milky Way is our home, and its story is in many ways our story too. The story of the Milky Way, with its grand scale and endless mysteries, is deeply intertwined with the story of humanity's quest to understand the cosmos. As our knowledge of the galaxy expands, so too does our sense of wonder at the complexity of the universe and our place within it. Each new discovery serves as a reminder that the Milky Way is not just a distant, impersonal collection of stars and gas, but a vibrant, dynamic system that has played a direct role in shaping the conditions that make life on Earth possible. At the heart of this relationship between the galaxy and life lies the concept of stellar evolution. The life cycle of stars is a fundamental process that governs not only the formation of planets, but also the creation of the very elements that are essential for life. When massive stars explode as supernovae, they release heavy elements like carbon, oxygen, nitrogen, and iron into space. These elements, forged in the fiery cores of dying stars, are the building blocks of planets, oceans, atmospheres, and even the molecules that make up living organisms. In this sense, the life and death of stars within the Milky Way are intimately connected to the rise of life on Earth. This cosmic cycle of creation and destruction is ongoing. New stars are being born in stellar nurseries scattered throughout the galaxy, while older stars burn through their fuel and reach the end of their lives. Some stars, like our Sun, will quietly fade into white dwarfs after shedding their outer layers. Others, much more massive, will end their lives in spectacular supernova explosions, seeding the galaxy with the raw materials for future generations of stars and planets. This continuous recycling of matter is one of the most profound aspects of the Milky Way's existence. A reminder that life itself is part of a larger cosmic process that has been unfolding for billions of years. But beyond the birth and death of stars, the Milky Way also holds clues to some of the most profound questions in science. What is the nature of the universe? How did it begin? What forces shape its evolution? The Milky Way is a microcosm of the larger universe, and studying its structure and behavior offers insights into the fundamental laws of physics that govern all of existence. One of the key areas of research within the Milky Way is the study of its central bulge, a densely packed region of stars that surrounds the supermassive black hole at the galaxy's core, Sagittarius A. The bulge contains some of the oldest stars in the galaxy, remnants from the early stages of its formation. Understanding the dynamics of the bulge and the role that Sagittarius plays in shaping the surrounding environment could provide important clues about the formation of galaxies and the role that black holes play in their evolution. Sagittarius Earth itself remains one of the most intriguing objects in the galaxy. Despite its massive size, about 4 million times the mass of the Sun, it is remarkably difficult to observe directly, hidden behind thick clouds of gas and dust. However, advances in radio and infrared astronomy have allowed scientists to study its effects on nearby stars and gas clouds. By observing the orbits of stars that pass close to the black hole, astronomers have been able to confirm the existence of this invisible giant and learn more about the extreme gravitational forces it exerts. Understanding the behavior of Sagittarius Earth is crucial not only for understanding the Milky Way, but also for broader questions about the role of supermassive black holes in galaxy formation and evolution. Another key area of research is the study of the Milky Way's dark matter halo. Although dark matter cannot be seen directly, its presence is inferred through its gravitational effects on the motion of stars and gas in the galaxy. Without dark matter, the outer regions of the Milky Way would not rotate as quickly as they do, and the galaxy itself would not hold together. Dark matter makes up the vast majority of the Milky Way's mass, yet its true nature remains one of the greatest unsolved mysteries in astrophysics. Various theories have been proposed to explain dark matter, ranging from exotic particles to new laws of physics, but so far, no definitive answers have been found. The study of dark matter is not only important for understanding the Milky Way, but also for unlocking the secrets of the universe as a whole. Dark matter is believed to play a critical role in the formation of galaxies, acting as a kind of cosmic scaffold that allows visible matter to clump together and form structures. Without dark matter, the universe would look very different, with far fewer galaxies and stars. As we continue to explore the Milky Way, researchers hope to find new clues that could help unravel the mystery of this invisible yet powerful force. Meanwhile, the exploration of the Milky Way is being revolutionized by new technologies and observational tools. Missions like the Gaia spacecraft are creating detailed, three-dimensional maps of the galaxy, allowing scientists to study the positions, motions, and properties of stars with unprecedented precision. These maps are revealing the intricate dance of stars within the Milky Way, showing how they move in response to the galaxy's gravitational forces, and how they have been shaped by past interactions with other galaxies. Gaia's data has also led to the discovery of new stellar streams, providing further evidence of the Milky Way's history of galactic mergers. Another exciting frontier is the study of exoplanets within the Milky Way. The discovery of thousands of planets orbiting other stars has fundamentally changed our understanding of the galaxy and the potential for life beyond Earth. Instruments like the James Webb Space Telescope and future missions will allow scientists to study the atmospheres of these distant worlds in detail, searching for signs of habitability and even life. The detection of biosignatures, gases like oxygen, methane, or other molecules associated with life, would be one of the most profound discoveries in human history, revealing that life may not be confined to Earth, but could be widespread throughout the galaxy. In this way, the Milky Way becomes not just an object of scientific study, but a canvas for our hopes and dreams about the future. The possibility of finding life beyond Earth, of understanding the true nature of dark matter, or of uncovering the forces that shape the universe. All of these goals are intertwined with our exploration of the Milky Way. Every new discovery brings us closer to answering some of the most fundamental questions about existence. Where do we come from? Are we alone in the universe? What is the ultimate fate of the cosmos? As we continue to probe the depths of the Milky Way, we are reminded that this galaxy is not just a distant abstract object, but a living, evolving system that has shaped the course of history on Earth. The stars, planets, and nebulae that fill the galaxy are not just points of light in the night sky. They are part of a vast, interconnected web of matter and energy that stretches across space and time. The Milky Way is our cosmic home, and its story is our story, a tale of creation, destruction, and renewal that is played out over billions of years. In the end, the study of the Milky Way is more than just a scientific endeavor. It is a journey of discovery that touches on the deepest aspects of human existence. As we look up at the stars, we are not just observing distant worlds, we are contemplating our place in the universe, seeking to understand the forces that have shaped our world and the possibilities that lie ahead. The Milky Way is both a reflection of the cosmos and a symbol of the endless curiosity that drives us to explore the unknown. It is a reminder that, no matter how far we travel, we are always connected to the stars, and that the story of the universe is, in many ways, the story of us all. The narrative of the Milky Way extends far beyond the physical realm, touching on the philosophical and existential questions that have driven human curiosity for millennia. As we gaze into the vast expanse of stars, we are prompted to confront not only the nature of the universe, but also the nature of our existence within it. The Milky Way, with its hundreds of billions of stars, is a reminder of both our insignificance and our profound connection to the cosmos. In its grand structure, we find the key to understanding the origins of not just the universe, but life itself. The Milky Way structure is also a subject of intense study. While we have long known that it is a barred spiral galaxy, recent research has revealed that its shape is more complex than previously thought. The galaxy's disk is warped and twisted, likely due to gravitational interactions with nearby satellite galaxies. In addition, the discovery of stellar streams, rivers of stars that were once part of smaller galaxies but have been torn apart by the Milky Way's gravity, offers a window into the galaxy's turbulent past. These streams are the remnants of ancient galactic collisions, and they help us understand how the Milky Way grew over time through the process of galactic mergers. At the same time, the study of dark matter continues to challenge our understanding of the Milky Way's mass and structure. Although dark matter cannot be observed directly, its gravitational effects are evident in the rotation of the galaxy. Without the influence of dark matter, the stars in the outer regions of the Milky Way would not orbit the galactic center as quickly as they do. This invisible mass, which makes up the bulk of the galaxy's matter, remains one of the greatest mysteries in modern astrophysics. Unraveling the nature of dark matter is crucial not only for understanding the Milky Way, but also for uncovering the fundamental laws that govern the universe. As we explore the outer reaches of the galaxy, we are also uncovering clues about the future of the Milky Way. One of the most dramatic events on the horizon is the eventual collision between the Milky Way and the Andromeda Galaxy, a neighboring spiral galaxy located about 2.5 million light-years away. Although this collision is still billions of years in the future, simulations suggest that the two galaxies will begin to merge in about 4 billion years. Over the course of millions of years, the Milky Way and Andromeda will combine to form a new, larger galaxy, radically altering the structure of both galaxies in the process. This cosmic collision, while dramatic, will not spell the end of the Milky Way. Instead, it is a natural part of the life cycle of galaxies. Throughout the universe, galaxies collide and merge, creating new structures and reshaping the stars and gas within them. The merger of the Milky Way and Andromeda will likely result in the formation of a massive, elliptical galaxy, fundamentally altering the night sky for any future observers on Earth, or whatever planet might host intelligent life at that time. The future of the Milky Way, then, is one of both transformation and continuity. While its current spiral shape will eventually change, the stars within it will continue to live, die, and give rise to new generations of stars and planets. In this way, the galaxy remains a symbol of the universe's ongoing cycle of birth, death, and renewal. As we look to the future of our exploration of the Milky Way, one thing is certain. The more we learn about our galaxy, the more we realize how much there is still to discover. Each new observation brings us closer to understanding the forces that shape the cosmos, yet each discovery also opens up new questions. The Milky Way, in all its complexity and beauty, is not just a place in the universe. It is a testament to the incredible diversity and wonder of the universe itself. In the end, our exploration of the Milky Way is more than just a scientific endeavor. It is a journey of discovery that connects us to the broader universe. By studying the stars, planets, and cosmic phenomena within our galaxy, we are learning not only about the cosmos, but also about ourselves and our place in the grand tapestry of existence. The Milky Way is our home, but it is also our gateway to understanding the infinite possibilities that lie beyond. The Milky Way's journey through time and space, like the universe itself, is an ongoing narrative of change, discovery, and interconnectedness. Every star, planet, and molecule in the galaxy contributes to the cosmic symphony playing out over billions of years, a process we are only beginning to comprehend. Yet, our exploration of this galaxy has brought us to the precipice of knowledge, with the promise of even greater revelations to come. One of the most striking realizations in modern astronomy is that the Milky Way is not an isolated system. It is part of a much larger cosmic structure known as the Local Group, which includes around 54 galaxies. Most of them smaller dwarf galaxies that orbit the Milky Way and its slightly larger neighbor, the Andromeda Galaxy. The Local Group is, in turn, part of an even larger structure, the Virgo supercluster, which contains thousands of galaxies spread across tens of millions of light-years. The Milky Way's relationship with these other galaxies highlights the interconnected nature of cosmic structures and the forces that shape them. Galactic interactions within the Local Group have played a crucial role in the Milky Way's evolution. The gravitational pull of the Milky Way has drawn in smaller galaxies, many of which have been torn apart and absorbed over time. This process, known as galactic cannibalism, has helped the Milky Way grow, adding stars, gas, and dark matter to its mass. Evidence of these interactions is seen in the form of stellar streams, remnants of smaller galaxies that were once independent but have been stretched and twisted by the Milky Way's gravitational field. These streams tell the story of the galaxy's violent past, revealing that the Milky Way, like all galaxies, is not a static object, but a dynamic system shaped by the forces of gravity, time, and energy. The future of the Milky Way is also tied to these cosmic interactions. As we've seen, the Andromeda Galaxy is on a collision course with our own, a process that will take billions of years to fully unfold. When these two galaxies meet, the event will not be an abrupt cataclysm but a slow, majestic merger. Stars from both galaxies will swirl together, creating new patterns and structures, while their central supermassive black holes may eventually merge as well, creating a powerful source of gravitational waves. This merger will result in the formation of a new galaxy, often called Milky Way. that will mark a new chapter in the cosmic story of the local group. As dramatic as this future event may be, the merger between the Milky Way and Andromeda is just one small part of the much larger narrative of cosmic evolution. The universe itself is expanding, a process that has been ongoing since the Big Bang. This expansion is not slowing down, it is accelerating, driven by the mysterious force known as dark energy. Over billions of years, this expansion will cause galaxies outside the local group to drift farther and farther away from us, eventually becoming invisible to any future observers as their light becomes stretched and redshifted beyond the limits of detection. In this distant future, the Milky Way, merged with Andromeda and the other galaxies in the local group, will exist in relative isolation. The rest of the universe will become unreachable, leaving the descendants of our galaxy in a dark and empty cosmos. While this scenario may seem bleak, it is the natural outcome of the universe's expansion, a reminder that even on the largest scales, nothing in the cosmos remains unchanged. Despite this ultimate fate, the Milky Way's story continues to inspire humanity. The study of our galaxy has brought about profound advances in our understanding of astrophysics, cosmology, and planetary science. Observations of the Milky Way have allowed scientists to refine their models of star formation, galaxy dynamics, and dark matter. They have also provided critical insights into the nature of black holes, supernovae, and the large-scale structure of the universe. At the same time, the exploration of the Milky Way has deepened our philosophical and existential understanding of the cosmos. The realization that we are part of a galaxy that is constantly changing, interacting, and evolving over billions of years reshapes our sense of identity. We are not separate from the universe, but are intimately connected to it, forged from the same elements that make up stars, planets, and galaxies. This cosmic perspective invites us to reflect on the nature of existence, the fragility of life, and the incredible journey that has brought us from the formation of the Milky Way's first stars to the emergence of intelligent life on Earth. The ongoing exploration of the Milky Way also brings new hope and opportunity. As our technological capabilities improve, so too does our ability to study the galaxy in greater detail. Space telescopes like the Hubble Space Telescope, Gaia, and the James Webb Space Telescope are revealing new facets of the Milky Way, uncovering its hidden structures and tracing the movements of its stars with unprecedented precision. Future missions will continue this work, providing even deeper insights into the forces that shape our galaxy. One of the most exciting frontiers of this exploration is the search for life beyond Earth. As we learn more about the planets within our galaxy, we are beginning to grasp the vast potential for life to exist elsewhere. From the moons of our solar system to the thousands of exoplanets that orbit distant stars, the Milky Way is full of worlds that may harbor the conditions necessary for life. The discovery of even the simplest forms of life on another world would have profound implications, altering our understanding of biology, evolution, and the place of humanity in the cosmos. In many ways, the study of the Milky Way is a journey into the unknown. With each new discovery, we are reminded that there is still so much we do not understand about our galaxy and the universe as a whole. Yet this sense of mystery is also a source of wonder, driving us to push the boundaries of knowledge and explore the farthest reaches of space. Yet the search for extraterrestrial life is not just about finding distant microbes or complex ecosystems, it is about understanding how life arises in the first place. Life on Earth is the result of billions of years of evolution shaped by the specific conditions of our planet and the broader environment of the solar system. By studying other planetary systems, we can begin to answer fundamental questions about whether life is a common outcome in the universe or a rare and perhaps unique event. Are the same processes that led to life on Earth at work throughout the galaxy, or is life an improbable accident in a hostile cosmos? The quest for life also raises profound philosophical and ethical questions. If we find life elsewhere, what will that mean for our sense of identity as a species? Will it unite us in the knowledge that we are not alone, or will it challenge our assumptions about our uniqueness in the cosmos? And if we encounter intelligent life, how should we respond? The search for extraterrestrial intelligence SETI has been actively scanning the skies for decades, hoping to detect signals from other civilizations. So far, no definitive signals have been found, but the search continues, driven by the hope that somewhere, among the billions of stars in the Milky Way, there might be other beings reaching out to make contact. Beyond the search for life, the Milky Way also holds clues to some of the deepest mysteries in modern physics. One of these mysteries is dark matter, an invisible substance that makes up about 85% of the total mass of the universe. Although we cannot see dark matter directly, we know it exists because of its gravitational effects on galaxies. Without dark matter, galaxies like the Milky Way would fly apart, unable to hold themselves together through the gravitational pull of their visible matter alone. Despite its importance, dark matter remains one of the most elusive phenomena in the universe. Scientists have proposed many theories about what dark matter might be, ranging from exotic particles to undiscovered forces of nature, but so far it remains one of the greatest unsolved problems in astrophysics. Dark energy, another cosmic mystery, is even more baffling. This force, which seems to be accelerating the expansion of the universe, was only discovered in the late 1990s. Its exact nature is still unknown, but it accounts for about 70% of the universe's total energy content. Together, dark matter and dark energy dominate the universe, yet they remain largely invisible to our current instruments. Understanding these forces is crucial not only for understanding the structure and evolution of galaxies like the Milky Way, but also for unlocking the ultimate fate of the universe itself. In the midst of these grand cosmic mysteries, the Milky Way remains a vital area of study, offering a laboratory where we can test our ideas about the universe. The galaxy is a vast system, full of diverse environments that range from the fiery star-forming regions of its spiral arms to the cold, ancient remnants in its halo. Each of these environments offers a different perspective on the forces that shape the cosmos. From studying the chemistry of star-forming regions to mapping the distribution of dark matter, scientists are using the Milky Way to probe some of the deepest questions in cosmology. As we push the boundaries of our knowledge, the tools of modern astronomy continue to evolve. Future missions, like the European Space Agency's Gaia spacecraft, are mapping the precise positions and motions of over 1 billion stars in the Milky Way, creating a three-dimensional map of the galaxy. This data will allow astronomers to study the structure and dynamics of the Milky Way in unprecedented detail, revealing the history of the galaxy and shedding light on its future. Other missions, like the upcoming Nancy Grace Roman Space Telescope, will focus on dark energy and the search for exoplanets, helping us to better understand the nature of the universe and our place within it. Ultimately, the story of the Milky Way is a story of exploration, not just of space, but of knowledge itself. As we continue to study the galaxy, we are also expanding the horizons of human understanding. Every new discovery, whether it be a distant planet, a star in its final stages of life, or a faint signal from the depths of space, adds to the collective knowledge of humanity. The Milky Way is our home, but it is also a gateway to the wider universe, a place where we can learn about the forces that govern all of existence. The future of Milky Way exploration is bright, as new generations of scientists, engineers, and dreamers take up the challenge of uncovering its secrets. The galaxy is vast, and our understanding of it is still in its infancy, but with each step forward, we come closer to answering the most profound questions of all. Where did we come from? Are we alone? And what is our place in the grand cosmic story that unfolds around us? In the end, the Milky Way serves as a reminder of the deep connection between humanity and the cosmos. We are not just passive observers of the galaxy, we are part of it, made from the same elements, subject to the same forces, and driven by the same curiosity that has propelled our species to explore the unknown. As we continue to study the Milky Way, we are also studying ourselves, tracing the path of cosmic evolution from the distant past to the far future, and seeking to understand the deeper meaning of our existence in this vast and beautiful universe. As we peer deeper into the Milky Way, we are reminded that this galaxy is not just a stage for cosmic phenomena, but also a reflection of the universe's larger mysteries and cycles. Each discovery we make, whether it is the birth of a distant star or the detection of a faint exoplanet, helps us understand the processes that govern not only the Milky Way, but the universe as a whole. The stars and planets we observe are shaped by forces that transcend space and time, connecting our existence to the origins of the universe itself. In this way, the study of our galaxy is the study of the cosmos writ large. One of the most fascinating aspects of the Milky Way is its role as a galactic cradle for planetary systems. When we consider the sheer number of stars within the galaxy, hundreds of billions, it becomes clear that our own solar system is but one small part of an immense interconnected cosmic network. Recent studies suggest that the majority of stars in the Milky Way likely have planets orbiting them, many of which could be rocky and Earth-like. This realization has profound implications for the search for extraterrestrial life and the understanding of planetary formation. The diversity of planetary systems within the Milky Way is astonishing. Some stars host gas giants like Jupiter, while others are orbited by small rocky worlds more similar to Earth. There are planets with rings larger than Saturn's, planets that orbit two suns, and planets that are scorched by the intense heat of their stars or locked in eternal ice. These worlds, scattered across the galaxy, provide a glimpse into the incredible variety of planetary systems that exist in the universe. Understanding how these planets form, evolve, and potentially support life is a key goal of modern astronomy, and each new discovery within the Milky Way brings us closer to answering some of the biggest questions in science. One particularly exciting discovery in recent years has been the identification of exoplanets within the so-called habitable zone, where conditions might be right for liquid water and, by extension, life to exist. The potential for life on other planets, even in microbial form, has captured the imagination of scientists and the public alike. Missions like NASA's Test Transiting Exoplanet Survey satellite and the James Webb Space Telescope are at the forefront of this search, helping us determine whether life could exist beyond Earth. The idea that life could be widespread in the Milky Way is both thrilling and humbling. If life is common, it suggests that the processes that led to its emergence on Earth are not unique, but rather part of the natural evolution of the universe. On the other hand, if we find that life is rare, it may imply that the Earth is a precious anomaly in a largely barren cosmos. In either case, the search for life has the potential to transform our understanding of biology, evolution, and our place in the universe. Yet, even as we search for life, the Milky Way also serves as a reminder of the profound beauty and mystery of the cosmos. Its spiral arms, glowing with the light of countless stars, are home to some of the most breathtaking phenomena in the universe. Nebulae such as the Eagle Nebula and the Horsehead Nebula are stellar nurseries where new stars are born. These regions, illuminated by the energy of young stars, are not just visually stunning but also hold the keys to understanding how stars and planetary systems form. Supernovae, the explosive deaths of massive stars, are another powerful reminder of the dynamic nature of the Milky Way. These violent events scatter heavy elements, such as carbon, oxygen, and iron, into space, enriching the galaxy with the building blocks of future stars and planets. Our solar system, and indeed all life on Earth, owes its existence to earlier generations of stars that ended their lives in supernovae. Without these cosmic explosions, the heavier elements necessary for life would not exist. As we continue to study the Milky Way, we are not just learning about the galaxy itself, but also about the broader universe. The processes that shape our galaxy, star formation, planetary evolution, the interaction of gravity and dark matter, are at work throughout the cosmos. By studying the Milky Way in detail, we are piecing together the larger puzzle of how galaxies form, evolve, and ultimately die. In doing so, we gain insight into the fate of the universe itself. Ultimately, the Milky Way is a reminder of both the vastness and the intimacy of the universe. It is vast, spanning distances that boggle the mind, filled with stars and planets beyond count. Yet it is also our home, the galaxy in which our solar system formed and where life on Earth emerged. As we look outward, toward the distant stars and the unknown realms of the galaxy, we are also looking inward, seeking to understand our origins, our future, and our place in the grand cosmic story. The Milky Way, in all its complexity and beauty, remains a symbol of the universe's boundless potential and the endless curiosity that drives us to explore it. The Milky Way is not only a stage for the cosmic dramas of star birth, death, and the formation of planets, but also a living record of the universe's past, present, and future. The stars that shine in our galaxy today are descendants of earlier stars, whose lives and deaths shape the very elements that compose everything around us. Our planet, our bodies, and the air we breathe. This intricate cosmic recycling, where dying stars explode in supernovae and scatter their enriched material across space, allows the formation of new stars and planets, a cycle that has been repeating for billions of years. In this context, our own existence becomes part of a much larger story. The elements that make up Earth and all life upon it, carbon, nitrogen, oxygen, iron, were forged in the hearts of long-dead stars. When we look at the Milky Way, we are, in a very real sense, looking at our ancestors. This connection between life on Earth and the cosmos is both profound and humbling. It reminds us that the boundaries between our world and the larger universe are more porous than they seem. We are not separate from the cosmos, we are born from it. The Milky Way's history is written in the distribution of its stars. Stars in the galaxy's disk tend to be younger, formed from the swirling gas and dust that continues to create new generations of stars. In contrast, the stars in the galaxy's halo, an extended region that envelops the disk, are among the oldest known. These halo stars are relics from the early days of the Milky Way, formed before the galaxy took on its familiar spiral shape. By studying the stars in different parts of the galaxy, astronomers can reconstruct its formation and growth, much like archaeologists piecing together the history of an ancient civilization from scattered ruins. One of the great unsolved mysteries of the Milky Way is how it came to be the way it is today. The galaxy did not form in isolation. It grew through the gravitational pull and eventual mergers with smaller galaxies. Evidence of this galactic cannibalism is visible in the form of stellar streams, remnants of ancient galaxies that were absorbed into the Milky Way. These streams, stretching across the sky like cosmic rivers, are a testament to the violent processes that shaped our galaxy. Over time, the Milky Way has devoured many smaller galaxies, adding their stars, gas, and dark matter to its own. The future of the Milky Way, like its past, is a story of change and transformation. One of the most dramatic events on the horizon is the impending collision with the Andromeda Galaxy. Though it may seem like a disaster waiting to happen, galactic collisions are surprisingly gentle on a stellar scale. The vast distances between stars mean that direct collisions between them are unlikely. Instead, the two galaxies will pass through each other, their stars, gas, and dark matter mingling, distorting, and eventually settling into a new, larger galaxy. This process will take billions of years to unfold, but when it is complete, the Milky Way as we know it will cease to exist, replaced by a new galaxy, often referred to as Milky. This cosmic collision will profoundly reshape the night sky. For billions of years, the view from Earth, or whatever planets might exist at that time, will be dominated by the glowing core of the Andromeda Galaxy as it draws closer. Eventually, the two galaxies will merge, and the spiral structure of the Milky Way will be transformed into a more elliptical shape. This future event is a reminder that galaxies are not static objects. They are constantly evolving, interacting, and reshaping themselves through the forces of gravity. But even beyond this collision with Andromeda, the fate of the Milky Way is tied to the ultimate fate of the universe. The universe itself is expanding, driven by a mysterious force known as dark energy. Over billions of years, this expansion will continue, causing galaxies to drift farther and farther apart. Eventually, if the current understanding of dark energy holds, the universe will reach a point where distant galaxies become invisible to us, their light stretched beyond the limits of detectability by the relentless expansion of space. In this far future, the Milky Way's descendants, merged with Andromeda, will find themselves in a lonely universe, with only the local group of galaxies remaining in view. However, even in this distant future, the processes that govern the Milky Way today, star formation, stellar evolution, and the recycling of elements will continue. Stars will continue to be born, live their lives, and die, contributing their material to new generations of stars and planets. Eventually, though, star formation will slow as the gas and dust needed to create new stars are used up. The galaxy will grow darker, populated mostly by long-lived, dim stars like red dwarfs. Over unimaginable timescales, even these stars will exhaust their fuel, leaving behind remnants. White dwarfs, neutron stars, and black holes that will slowly cool and fade. In the end, the Milky Way, like all galaxies, will grow cold and dark. This is the fate of the universe as we currently understand it. A slow, inexorable decline into darkness, often referred to as the heat death of the universe. It's a fate dictated by the second law of thermodynamics, which tells us that entropy, the measure of disorder in a system, will always increase. As stars burn their fuel and energy is radiated away, the universe becomes more disordered and less capable of sustaining the kinds of dynamic processes that allow for life, stars, and galaxies. Yet, despite this seemingly bleak future, the story of the Milky Way is one of beauty, complexity, and discovery. From its birth billions of years ago to its eventual merger with Andromeda and beyond, the galaxy has been and will continue to be a source of wonder and inspiration. It is a reminder that we are part of something much larger than ourselves, a cosmic journey that began long before us and will continue long after we are gone. As we look to the future, the Milky Way remains a focal point for our quest to understand the universe. Each new discovery, whether it be a new exoplanet, a distant star, or a dark matter signal, adds to our knowledge of this grand cosmic system. The galaxy is not just our home, it is a living, evolving entity, a microcosm of the universe itself. By exploring the Milky Way, we are, in a sense, exploring the fundamental nature of reality, the forces that shape everything from the smallest particles to the largest cosmic structures, and in doing so we are also exploring ourselves, our origins, our destiny, and our place in the cosmos. As we continue to explore the Milky Way, our understanding of the universe grows deeper and more complex. Yet each new discovery within our galaxy seems to raise as many questions as it answers, sparking fresh curiosity about the forces that govern the cosmos. One of the most enduring questions is how life fits into this vast cosmic landscape. Are we the only intelligent beings in the Milky Way, or are there other civilizations scattered among the stars, perhaps even looking up at their own night skies, wondering the same thing? The search for extraterrestrial life has long been a central focus of astronomy and planetary science. With the discovery of thousands of exoplanets, planets orbiting stars other than our Sun, the possibility that life could exist elsewhere in the galaxy has shifted from speculation to serious scientific inquiry. Many of these exoplanets are located in what astronomers call the habitable zone, the region around a star where conditions might be just right for liquid water to exist, a key ingredient for life as we know it. The tantalizing possibility that life could emerge under similar conditions on other planets has inspired a new generation of missions aimed at detecting the signatures of life, or biosignatures, on distant worlds. One of the most promising tools in this search is the James Webb Space Telescope, which is capable of analyzing the atmospheres of exoplanets for chemical compounds that might indicate the presence of life, such as oxygen, methane, or other organic molecules. This kind of research could reveal whether planets within the Milky Way harbor microbial life or even more complex organisms. The discovery of life beyond Earth, even in its simplest forms, would be one of the most profound scientific discoveries in history, fundamentally altering our understanding of biology, evolution, and the place of humanity in the universe. The Milky Way galaxy, often described as our stellar metropolis, is a rich tapestry of stars, dust, gas, and dark matter, woven together by the forces of gravity and time. It spans a staggering 100,000 light-years across, yet it is just one of billions of galaxies in the observable universe. The Milky Way holds a special place in human consciousness. It's the galaxy that gave birth to our solar system, the cradle of our existence. When we gaze at the night sky and see the faint, milky band of light stretching across the heavens, we are witnessing a cross-section of this immense structure, a reminder of the deep connection we have to the cosmos. As a barred spiral galaxy, the Milky Way is a quintessential example of cosmic order and complexity. Its spiral arms, rich with new stars, star clusters, and nebulae, trace graceful arcs outward from the dense, elongated bar at the center. These arms are the site of ongoing star formation, a vivid testament to the dynamic processes at work in the universe. Our Sun and its planets, including Earth, reside in the Orion Arm, orbiting the galactic center at a leisurely pace of 230 kilometers per second. This journey around the center of the Milky Way takes approximately 230 million years to complete, a staggering period known as the cosmic year. At the core of the Milky Way lies its most enigmatic feature, the supermassive black hole Sagittarius A. With a mass equivalent to millions of suns, Sagittarius Arth exerts a profound influence over the surrounding stars and gas, anchoring the galaxy in a gravitational embrace. Despite its size, it is invisible to optical telescopes, concealed by thick veils of gas and dust. Only through the advances of radio astronomy and other specialized instruments have we been able to study this massive yet elusive object. Black holes like Sagittarius Arth are thought to play a pivotal role in galaxy formation and evolution, acting as both engines of growth and silent overseers of galactic stability. The Milky Way itself is on the move, part of a larger cosmic community known as the Local Group. This group includes several dozen galaxies, with the Milky Way and Andromeda being the dominant members. These two giant galaxies are locked in a gravitational ballet, steadily approaching each other over the course of billions of years. In roughly 4 billion years, they will merge in a spectacular collision, forming a new, larger galaxy that will alter the landscape of the local cosmos forever. This grand event, while seemingly catastrophic, is part of the natural life cycle of galaxies, a process that has unfolded countless times since the dawn of the universe. Within the eons of the Milky Way, regions known as stellar nurseries illuminate the galaxy's ongoing cycle of birth and death. These clouds of gas and dust, like the famous Orion Nebula, collapse under the force of gravity to give rise to new stars, some of which will eventually host their own planetary systems. It is within these nurseries that the seeds of new solar systems, much like our own, are sown. The Sun itself was born in such a region some 4.6 billion years ago, emerging from the dust and gas of an earlier generation of stars. Understanding these processes allows us to trace the origins of not just our solar system, but of life itself. One of the most compelling questions driving modern astronomy is whether life exists elsewhere in the galaxy. With the discovery of thousands of exoplanets, many within the so-called habitable zone where conditions might support liquid water and, potentially, life, this question has gained new urgency. The search for extraterrestrial life, whether it be microbial or intelligent, is not just about finding others, it is about understanding the universality of the processes that led to life on Earth. Instruments like the James Webb Space Telescope are poised to give us unprecedented insights into the atmospheres of distant worlds, searching for signs of life beyond our planet. As we explore the Milky Way, we are also piecing together the larger story of the universe itself. Each star, each planet, each nebula is a chapter in the history of cosmic evolution, stretching back to the earliest moments of the Big Bang. The different generations of stars tell us about the cycles of matter in the galaxy, with heavier elements forged in the hearts of dying stars and scattered across space by supernovae. These elements, including the carbon, oxygen, and nitrogen that make up the building blocks of life, are recycled into new stars and planets, ensuring that the galaxy, and life itself, continues to evolve. The Milky Way is a dynamic, living system, a cosmic ecosystem that is constantly changing and adapting. As we continue to probe its mysteries, we deepen our understanding not only of the galaxy we call home, but also of the universe at large. The Milky Way is not just a backdrop to our lives. It is an integral part of the cosmic story, a story that we are only beginning to unravel. Each new discovery, each new observation, brings us closer to understanding our place in the grand scheme of the cosmos and the future that awaits us among the stars. The Milky Way, despite being just one galaxy among billions, represents a microcosm of the processes that govern the universe at large. Its stars, planets, gas clouds, and dark matter create a complex and interwoven system, where every part plays a role in the evolution of the whole. From the smallest grains of cosmic dust to the immense gravitational forces of black holes, the Milky Way is a laboratory where the laws of physics unfold on a grand scale, giving us a glimpse into the fundamental workings of the cosmos. The galaxy's spiral arms are more than just striking visual features, they're regions of intense activity. These arms are home to vast molecular clouds, the birthplaces of stars, where gravity pulls gas and dust together to form new suns. As stars are born, they ignite, fusing hydrogen into helium and releasing vast amounts of energy. This energy, in turn, shapes the surrounding environment, triggering the birth of more stars and dispersing the gas that fueled their creation. Over time, the stars drift away from their birthplaces, spreading across the galaxy in a process that has been ongoing for billions of years. In the Milky Way's disk, stars like our Sun follow orbits around the galactic center. However, the galaxy's structure is not limited to this flat plane. Surrounding the Milky Way is a spherical halo populated by older stars and globular clusters. Ancient, tightly bound groups of stars that formed in the early stages of the galaxy's history. These clusters are like time capsules, preserving a record of the conditions that existed when the Milky Way was young. By studying them, astronomers can learn about the galaxy's origins and its earliest phases of development. One of the most intriguing aspects of the Milky Way is the presence of dark matter. Although it is invisible and does not interact with light, dark matter exerts a powerful gravitational influence, shaping the galaxy's structure and motion. Without dark matter, the stars in the outer regions of the galaxy would not move as they do. Its gravitational pull is essential to maintaining the galaxy's form. While the true nature of dark matter remains one of the greatest mysteries in modern science, its role in the formation and stability of galaxies like the Milky Way is undeniable. Its invisible presence surrounds us, holding the galaxy together in ways that we are only beginning to understand. As we peer deeper into the galaxy, we uncover its rich diversity. The Milky Way is home to stars of all ages and sizes, from massive blue giants to faint red dwarfs. Some stars are only a few million years old, blazing brightly but destined to burn out quickly. Others, like our Sun, are middle-aged, providing a stable environment for the development of life. There are also ancient stars, relics from the galaxy's early days, that have been shining for more than 10 billion years. These different generations of stars tell the story of the galaxy's ongoing evolution, revealing how the Milky Way has grown and changed over time. In addition to its stars, the Milky Way is rich in planetary systems. The discovery of exoplanets, planets that orbit stars beyond our Sun, has revolutionized our understanding of the galaxy. With thousands of exoplanets identified so far, astronomers now believe that most stars in the Milky Way host planets. Some of these planets are small and rocky like Earth, while others are gas giants or icy worlds orbiting far from their stars. The diversity of planetary systems suggests that the galaxy may be teeming with worlds that could harbor life, or at least the conditions for it to emerge. The search for life beyond Earth is one of the most exciting scientific endeavors of our time. While no definitive evidence of extraterrestrial life has yet been found, the discovery of potentially habitable planets within the Milky Way raises profound questions. What conditions are necessary for life to develop? Could life exist in forms radically different from what we know? And if we do find life elsewhere, what would that mean for our understanding of the universe and our place within it? In the coming decades, new technologies and missions will allow us to explore these questions in unprecedented detail. Space telescopes, like the James Webb Space Telescope, are already beginning to probe the atmospheres of distant exoplanets, searching for signs of water, oxygen, and other markers of life. Meanwhile, missions to moons like Europa and Enceladus, in our own solar system, where subsurface oceans may exist, hold the promise of revealing whether life could have taken hold in environments far different from Earth's.